Hey, what up guys? Today I'm going to show you how to 3D print a fan mount for your RC car from scratch. If you're into 3D printing and RC cars, follow along and I'll show you how it's done. First step is getting the printer prepped. My printer is a Snapmaker Artisan, and I have to put the slurry on the bed for every print. I have to scrub clean the print nozzle for every print after preheating it. Then I have to preheat the bed, bake that, I use rubbing alcohol and school glue. Bake that on, let it cool to get that fully prepped. And then my machine works best if I do a Z offset every single time. So for every single part, I go through this. So when you're buying 3D printed RC parts off of eBay, I hope this helps you understand the process involved and gives you a little more respect for the guys that are 3D printing that stuff. It's not always that very easy. So, you know, it's pretty amazing how little they actually charge to get this done. This here is Tinkercad. It is a free online CAD system. And I've been designing a lot of parts in here. You can do 3D designs, all sorts of good stuff. You can upload your 3D scans into here as long as they're not too big. It's not super high resolution, so it does leave little polygons everywhere, but it's pretty cool for a free service. I get a lot of stuff and engineering done for these here cars. Alright, so after you make your design, you export your part, export, STL file, open the folder, here it is right there, open your Cura, this is the slicer, this is the software that goes along with a 3D printer. You put your part in there, get it orientated the way you want. I'm going to rotate this onto a face and put that side down because I believe that my design will allow it to be printed without supports. Now a lot of 3D printing is done with supports, which adds even more labor to remove those supports, trim any sharp edges, and maybe sand the part or prep it. If somebody is super good with their settings, sometimes they can run them off without these issues. Or not issues, they're not really issues, they're just native to the this type of manufacturing typically. But if somebody's very good with their settings, they're able to eliminate a lot of the extra work, but not all of it. So, you know, when you're paying $15 or $30 for a 3D printed bracket on eBay, that is really cheap for the amount of labor and time that went into it. For instance, it took hours of CAD work to actually design this fan mount completely from scratch. Anyhow, once you get it loaded into your slicing environment, you come in here, you have a bazillion settings that you have to make sure are just right for the type of part you're making, the material you're using. You got to make sure you have the correct material. So there's a lot of research to be done there with all this stuff. There are so many settings, and having one setting off is the difference between having, look at this, it goes on and on and on. And if you have one setting off, each and every single setting that is not quite right will inhibit your print or your print quality, leaving either more labor to be done or having to start completely from scratch. Anyhow, I like to use a 1mm nozzle, and my settings for the PET G aren't very sound. I do actually have to go through and set some. I'm not going to show you all that, but then you hit the slice button. This one happens to be a 30-minute print, so that's 40 minutes of machine time. That's only at a 0.3 layer height, and that is, if I remember right, that is a blazing fast. I gotta slow it down actually because it didn't print super great the last time. Now it's a 45-minute print. I'm going to send it to my machine, which is still just warming up. Alright, now I've sent it over to the machine. You guys might have heard the ding. It's pretty quick, depending on how big the part is and how big the G code is. Sometimes it's a several minute process to upload. I do it wirelessly through my Wi-Fi. Here's my bed. It is almost preheated. My extruder is now pre-warmed. So now I can take this fancy wire brush, clean off this preheated nozzle, and make sure it's real good. Gotta make sure you don't get any debris on the tracks. Gotta make sure you clean that if you do. This is cooling down just a little bit, which is good because then the glue will set up. Okay. Then come over here. Control. Calibration. I'm going to just do a Z offset because I just recently did the bed leveling. This is the short version of setting the machine. This is just a blazingly fast process that is super intriguing and not boring or repetitive or otherwise annoying at all. It's just touching the print nozzle off. Now remember, I have to do this with every part if I want success. I haven't had a program that I've been able to just run without doing this part every time and have it be very successful. I've had a few parts, but usually only in PLA, which is a much more forgiving filament. I like to print my RC parts in PETG because it's a little bit more durable, quite a bit more heat resistant, and you know, it's still flexible and inexpensive as far as filaments go. I would like to make the switch over to polycarbonate. However, polycarbonate uses a very high printing temperature. My machine is supposedly capable, but it can also produce some toxic fumes. So I have a little kid, and so I kind of avoid that for now. But it will be something I may experiment with in the future. Alright, now that that is all prepped, you'll start the program. It gives me a warning because I have my machine set up differently than it thinks. And now it's time for it to actually warm up, which will take anywhere from 15 to 20 minutes, depending on your machine. So, you know, we just did some preheat to it, so it's already 50 degrees on the bed. It's going to go up to 70 before it starts printing. The nozzle heats up quicker than the bed does, but they both turn on at the same time. So there's a few extra minutes, another 10-15 minutes of a guy's life right there. Alright. The print is now done. And the settings were not quite right. That is definitely not going to survive being an RC truck. But I can at least use it to test it and prove that it will work. I've already made some new settings to hopefully print this thing in a usable fashion, but obviously too little wall right here. I think I need to also change my small layer settings. And here is a top that I also printed in a previous run. As you can see, that 1mm nozzle and not having the best print settings in the world leave a lot to clean up. If I was mass producing these, I'd be more concerned about that. Alright, after about half an hour cleanup, almost 2 parts, I ended up with these. This one printed with such a thin wall that one of the legs actually cracked while I was dressing it up. That's okay. I already reprogrammed it to print with 3 walls instead of a single wall. So the material will end up being 3 millimeters thick per wall as opposed to 1. This one is still just going to be 1 millimeter thick per wall. And I'll show you how to assemble them. For this particular build, I'm using these King Val billet-bodied cooling fans, and they will be sandwiched between these 2 layers. I did leave a hole here that was intended for one of the plugs to fit through. It wasn't quite big enough, so that will either have to be drilled out or redesigned. And they will go side by side like this. These are M3 screws, so they actually measure 2.92 on their major diameter, which is the outside diameter of a thread. I'm actually going to drill them out to close to 2 millimeters. Just so those threads have some squeeze. Alright. Here, I am preloading 2 screws on each end just to give the fans something hope to line up. Again, if this was not a prototype unit, that would be a little bit better sorted, the hole size. You can see the fan mounts on the other side of the top horn. These are King Val fans that you can get for about 25 bucks a pair. 40 millimeter by 8 millimeter, 21 or 2600 RPM fans. As you can see, this design works. This is an M3 by 18 button head screw. Punch them up by hand. All right. And there you have it. From scratch. 3D printing your own RC car fan mount. If you guys are into RC cars, keep an eye out for the video where I actually install this in my X-Maxx and then go bash it to see how these King Val fans actually hold up. Until then, I will have a link below for the STL files in case you have your own printer. And then maybe an email address or something. You can hit me up in the comments and let me know if you want this printed for your own car, and maybe I'll put kits together and pop them on eBay or something. Depending on whether people want this or not, but yeah. That is 3D printing an RC car fan mount for an X-Maxx from beginning to end. Alright guys, thanks for tuning into this video, and if you like this video, please hit that thumbs up, hit that subscribe button, hit the bell, all the blah 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 blah. Alright guys, be good to each other out there. Peace.